Hi boys and girls, this is your math e-learning lesson for Wednesday, May 6th. Today we're going to be looking at the review for test 25, so we'll be using 25A for our review. Let's take a look. Number 1, tickets for the zoo cost $5.15 for adults and $1.30 for children. Gary bought tickets for 2 adults and 3 children. Altogether, how much did the tickets cost? Well, we have multiple steps going on in this problem, so we do need to break it down and take a look at it slowly. So we have tickets for the zoo cost $5.15 for adults. So let's move this over here like this, and let's do $5.15 for adults, and then it's $1.30 for children. So it's $5.15 for adults, $1.30 for children. Now it said that Gary bought tickets for 2 adults. So that's 2 adults and 3 children. Altogether, how much did the tickets cost? So now we know that he bought 2 adult tickets. Each ticket cost $5.15. And he bought 3 children's tickets, and each one cost $1.30. So now we can use that information to solve the problem. So $5.15 times 2 for the 2 adults tickets, and you multiply. 2 times 5 equals 10. 2 times 1 equals 2, plus 1 equals 3. Bring down your decimal point, and 2 times 5 equals 10. So we know now that for the adults, it costs $10.30. Now for children's tickets, it was $1.30 for each child's ticket, and we needed to buy 3 of them. So we multiply the $1.30 times 3. 3 times 0 equals 0. 3 times 3 equals 9. 3 times 1 equals 3. Decimal point, $sign. So now we know that it costs $10.30 for the adult tickets, $3.90 for the children's tickets. Now the problem does ask us altogether, how much did the tickets cost altogether? So now what would be your final step? Looking at how much was spent altogether, you're going to need to add the adult tickets plus the children's tickets. So we have $10.30 plus the $3.90. So we add that, 0, 3 plus 9 is 12, 1 plus 3 is 4, 1 plus nothing is 1. Again, remembering to bring down the decimal point and bring down the $sign. And so our total altogether is $14.20. $14.20. So again, it was $5.15 for each adult ticket, and there were 2 tickets purchased. It was $1.30 for each child, and there were 3 children's tickets that were purchased. So you multiply the price of the ticket times the number of those tickets they needed, and then after you did that, then you took what we call those subtotals and added them together for that final total, or that grand total. So the final cost would be $14.20. Again, not difficult to do, just need to take your time and go through it step by step. Let's move on to number 2. Here we're talking about estimating area. So here it says to estimate the area of the triangle. Each small square is 1 square centimeter. So we need to estimate the area of the triangle. And again, they tell you each small square is 1 square centimeter. Now, thinking back to when we did estimating area, we found that the easiest way was to first count up all of the whole squares that you have. So let's start here. We have 1, 2, 3. That's pretty much a whole one, so that's 3. 4, 5, 6, 7, 8, 9, 10, 11, this is pretty much a whole one, 12. So we have pretty much 12 whole squares. And then anything that is a half or greater, we count as a whole. So we have 12 that were definitely whole squares. This is more than a half, so that would count as 1. That's 13. This is another one, 14. Another one, 15. Over here, this would be 16. This is a half, so that would be 17. This is more than a half, that would be 18. And this is a half, that would be 19. Okay, so the estimated area here would be 19 square centimeters. Now remember that it is an estimate. The reason it is an estimate is because we are counting up the number of square units, because with area you're looking for the number of square units. So that basically means the number of squares that it takes to cover the surface. So in an odd shape, or a shape that doesn't have your straight sides where you can get those whole squares, what you do is you look for how many whole squares you do have within the figure, and then every half or anything greater than a half of a square you count as a whole square. Okay? The other way you could do it would be to actually look at those pieces that were not whole squares, and then you can match them up and say, oh well, here's a half and here's a half, so that makes a whole. Or maybe over here you have 3/4 of a square, and here you have 1/4, and that makes a. So you could piece it together that way, but that becomes much more complicated. And so an easier way to do it is to count up the whole squares, and then anything that is a half or more than a half of a square you count as a whole square. And again, it is just an estimate. Okay? All right, looking ahead to number 3, it says 8/4 is the same as how many nickels? 8/4 is the same as how many nickels? Well, in order to figure out how many nickels, you first need to know what you have when you have 8/4. First of all, every time you have 4/4, you have how much? Okay, $1. So if you have 4/4, then that equals $1. Another 4/4 equals another $1. 4/4 and 4/4 make 8/4. $1 plus $1, $2. So you have $2. So the amount of money that we're looking at here is $2. Okay, so you have $2. Now, if you have $2 in nickels, how many nickels is that going to be? Remember that nickels are each worth 5 cents. So, easiest thing to do, we're looking at how many nickels in $2. Start first by how many nickels in $1. And so you would simply then, you can count by 5s to see how many nickels you have in $1. Okay. How many nickels does it take to equal $1? You have 20 nickels. So 20 nickels in $1 and 20 nickels in another dollar. That gives you your 40 nickels. Okay, it's a total of 40 nickels in $2. Okay. All right, number 4. Something is wrong with this sign. Draw 2 different signs to show ways to correct the error. Well, first off, you need to take a good look and ask yourself, well, what is the error here? What is wrong with this sign? And so when you take a look, you see that you have a 0, decimal point, 45, and then you have a cent sign. You need to remember that it is the $sign and decimal point that works together, and that the cent sign stands alone. So your $sign and decimal point work together, the cent sign stands alone. So this is supposed to say 45 cents. Well, then you either need to use the $sign and the decimal point, like this, 45 cents, or you would simply write 45 and the cent sign. Two different ways to write it, but you do not combine a cent sign with the decimal point. They do not go together. Remember, the pair is the dollar sign and decimal point, and the cent sign stands alone. Number 5. What fraction of the letters in aardvark are not A's? What fraction of the letters in aardvark are not A's? Well, again, when you're talking about a fraction, you know that the denominator, the bottom number in a fraction, will be the total number of parts or pieces that you have. So in this case, if we're going to be writing a fraction, then we need to look for our total number of parts. And in this case, the parts are the letters. So in aardvark, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 letters in aardvark, so that means that our denominator would be 8. Now, for the numerator, it says what fraction of the letters are not A's. So looking for those letters that are not A's, we have an R, a D, a V, and a K. So we have 4 letters. I missed another R here. Okay, we have 5 letters that are not A's because you have an R, a D, a V, an R, and a K. So you have 5 letters that are not A's. So 5 out of 8 are not A's. If the question was what fraction of the letters in aardvark are A's, your answer in that case would be 3/8 because 3 letters out of the 8 letters are A's. Okay, what fraction are not A's? That would be 5/8 because 5 out of the 8 letters are not A's. Okay, number 6. What fraction name for 1 has a denominator of 6? A fraction name for 1 that has a denominator of 6. Well, if it has a denominator of 6 and it is a fraction name for 1, the numerator must also be 6 because our fraction name for 1 are fractions where the numerator is the same as the denominator. Anytime the numerator is the same as the denominator, you have a fraction name for 1. So if this fraction has a denominator of 6, it's also going to have a numerator of 6. Number 7. Draw a picture to show that 1/4 and 2/8 are equivalent fractions. I'm going to move this out of the way, and we're going to show that 1/4 and 2/8 are equivalent fractions. So we want to draw a picture. It does not ask for circles. Sometimes it'll ask specifically for circles or for squares. This does not ask for anything in particular. So we want to show that 1/4 equals 2/8. So here we have a circle divided up into 4 equal parts. One of those parts would be shaded in. There's our 1/4. Well, we want to show that that equals 2/8. So again, equal sign. Draw another circle. It should be pretty much the same size as the first. We're going to now divide this circle up into 8 equal parts. And we want to show that 2 of those parts is the same as one of these. So we color in 1, 2 out of the 8 parts. And we can see that 1/4 is equal to 2/8. The same portion of each circle is shaded in. In the first circle, you had 4 equal parts. In the second circle, you had 8 equal parts. 1/4 equals 2/8. Okay, let's take a look now at number 8. Number 8 says, the championship bike rider, looking a little blurry here, okay. The championship bike rider, the champion bike rider could ride 56 miles in 2 hours. At the same speed, how far could he ride in 6 hours? Okay. he could ride 56 miles in 2 hours, going at the same speed. How far could he ride in 6 hours? So you have 56 miles in 2 hours. Okay, 56 miles in 2 hours. Traveling at that speed, then how far could he ride in 6 hours? Well, there are a few different ways you can do that. And you can say, well, we already know it's 56 miles in 2 hours. We're looking at, well, then how far in 6 hours? Well, you have 2 hours. Another 2 hours is 4 hours. And another 2 hours is 6 hours. So it's 56 miles in 2 hours. It's going to be 56 miles in the next 2 hours, and then 56 miles in the next 2 hours. So you have 56 3 times. You can just add that up. 3 6s is 18, 3 5s is 15, and 1 is 16. And you have a total of 168 miles in 2, 4, 6 hours. Okay, so that was one way that you could very easily then figure out. Again, looking at what you had, 56 miles in 2 hours. So if you travel for 6 hours, that's 2, 4, 6. And it means 56 miles in each of those 2 hours. Okay. Another possibility was, you look at the 56 miles and you say, well, if we travel 56 miles in 2 hours, how far do you travel in just 1 hour? In just 1 hour. And so then you can say, well, we can take the 56 and we can actually divide that by 2 so we can see how far is being traveled each hour. And 5 divided by 2 is 2, because 2 times 2 is 4 with 1 left over, and 16 divided by 2 is 8. So you see that you have 28 miles per hour. So now you can say, well, 28 miles each hour if I travel for 6 hours. So then you multiply 28 times 6. 6 times 8 equals 48. And 6 times 2 is 12, plus 4 is 16. And there you have your 168 miles. So again, remember, more than one way that you can go about trying to solve the problem. Sometimes just sort of listing things out like this gives it to you where you can see it, so you can visually look at it and know how far he traveled. Or again, really going a little bit deeper mathematically, where you're actually dividing the 56 by 2 hours to see how far is he actually traveling per hour, and it's 28 miles per hour, and then you can multiply miles per hour times the number of hours traveled, and you get your answer of 168 miles. Okay. All right, let's move on to number 9. Number 9 says, the bikers bought 10 caps for $3.30 each, and 7 straps for 80 cents each. Sales tax was $2.85. If they paid for the items with the $50 bill, how much change did they receive? Well, if you only read through this problem one time, it's going to seem very overwhelming, because there's a lot that's going on here. So what you need to do, as I always tell you, you need to read through at least one time, make sure you have an understanding of what's going on, and then go back and break the problem down a little bit. Okay, so let's go back. Okay, we're going to need more space for this. And so we see the bikers bought 10 caps for $3.30 each. So we have 10 caps at $3.30 each. Okay, we're just going to sort of list out our information. Then we know that there were 7 straps at 80 cents each. We also know that there was sales tax of $2.85. Okay, And then if they paid with a $50 bill, how much change did they get back? Well, we're not ready to figure out the change yet. Right now, we first need to figure out how much money was spent. Remember, anytime you have a question where you're looking to see, well, how much change did you get back after buying this, this, and this? The first thing that you always need to do is to figure out your total. What is the total amount of money that you are spending? Once you know how much money you're spending, then you can very easily figure out how much change you get back. But you have to have that total amount being spent first. So let's go back and take a look at this. So if we buy 10 caps at $3.30 each, you need to work that out to see how much money you're spending on caps. $3.30 times 10. We hang off that 0, so we can just put our 0 down. And then you're saying 1 times the 0, which is 0, 1 times 3, which is 3, 1 times 3, which is 3. Put your decimal point where it belongs and bring down the dollar sign. Or you could have recognized that when multiplying by 10, all you really needed to do was to take the original amount, $3.30, add a 0 to it, and then move the decimal point where it belongs for dollars and cents. Okay, but anyway, we have our $33 was spent on the caps. Now, the straps cost 80 cents each, and 7 of them were purchased. So we have 80 cents each times 7. 7 times 0 is 0. 7 times 8 is 56. 7 times 0 is 0. Plus 5 is 5. Bring down our decimal point and dollar sign. So $33 was spent on the caps. $5.60 was spent on the straps. And don't forget, we had that tax of $2.85 that we need to add on. Remember that you need to pay tax. You need to pay tax. That's like adding on the cost of another item. When you have tax, you have to add that on. It's something that you must pay. So we add here 0, 0, and 5. That gives us 5. And then here we have 0 and then 6 plus 8. So that's 14. Put down the 4, carry over your 1. 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 2 equals 11. Put down the 1, carry over the 1. 1 plus 3 is 3. Bring down your decimal point and your dollar sign. So you have a total of $41.45. However, even after doing all of this work, we are not finished. We do not have the answer for the question yet, because remember, the final question was, if they paid for the items with a $50 bill, how much change did they receive? Well, they spent $41.45. They're paying with a $50 bill. So now you have to say $50 minus that $41.45. Okay, you have all the zeros, so you're going to have to come all the way over here to the 5 to trade. 5 becomes 4, 0 becomes 10, that 10 now becomes a 9. Now this 0 becomes 10, now we can trade from that 10, which becomes 9, and this 0 becomes 10. 10 minus 5 equals 5, 9 minus 4 equals 5, bring down the decimal point, 9 minus 1 equals 8, 4 minus 4 equals 0, bring down the dollar sign. So here we have our final answer of $8.55. Okay, $8.55. It wasn't a difficult problem. The numbers weren't hard to work with. You just needed to work through it step by step, breaking it down. And often it just makes it easier if we list out the information this way, rather than having to keep going back into the problem and rereading what it says. We sort of make that list for ourselves. Okay, so again, in this case, you needed to list out all of the purchases. So that was the caps, how much did the caps cost, how many were they buying, the straps, how much were the straps, how many were they were buying. You also need to add on tax. As I mentioned, you must pay tax, so that's like adding on another item that does get added on. right? And then after you had that total, which was over here at $41.45, then you can work on figuring out the change, because now you know how much the purchases cost. Okay, they were spending $41.45, and if you pay with a $50 bill, you end up with $8.55 change. Okay, a lot of work going through that one, but you can certainly do that if you just work carefully with it. Okay, and then number 10, it says 49 people stood in line. 6 of them could ride in each car. If there were only 5 cars, how many people did not get a ride? Did not get a ride. Again, it's not that it's a difficult problem. It's just one you're going to need to work through step by step. So you have 49 people. Okay, so all 49 people want to ride. 6 of them can ride in each car. If there are only 5 cars, how many people did not get a ride? You have 6 in each car, you have 5 cars. So if you have 6 people, or rather 6 people who could ride in each car, and you have 5 cars, okay, 6 people can ride in each car, 5 cars, what are you going to do? You're going to multiply. If you have 6 cars, you put 5 people into each of those cars, that means 30 people can ride in the cars. If you have 49 people waiting in line, you can only get 30 people in the cars. You have 49 online. The question is then, how many do not ride? So now you're going to subtract. You have a total of 49 people. You only have enough space for 30. You subtract and get your difference of 19, and there are 9 people then who are not going to be able to get a ride. Okay, again, you only have seats for 30. 6 people in each car, you have 5 cars. 6 times 5 equals 30. You have only enough space for 30, and you have 49 people waiting to get on, waiting for a ride. So then you subtract, the difference is 19. So 19 people will not have a ride. Okay, and then the rest of the page, you have your straight computation, but I do want to go over a couple of things here with you. Let's look at numbers 11 and 12 especially. 11 and 12. Okay, number 11 shows that you have 26.31, you have 6.83, and you have 12.9. Okay, these are decimals that you need to add. Okay, but again, you need to make sure that you are lining them up by the decimal points. Once you do that, then you will be able to add and get a correct answer. It's fine that there is nothing here. That's not going to affect your answer. If you wanted, you can fill in that 0, okay, to make it easier for you to see that that will not change your answer. But again, the importance of lining up those decimal points. Okay, in number 12, you have 134 and 55 hundredths, or 134.55, minus 23.9. And here we are again, where you need to make sure you're lining up your decimal points, and it's okay to fill in that 0 so that you make sure that you are subtracting correctly. There are times, and I don't see any of those examples here, but there are times where it's going to be necessary that you do fill in that 0 up above. Let me just change this up so that I can show you what I mean. That was going to be 2, make that a 9. Okay, so if we were looking at this problem, it's still a subtraction problem that can be done. However, over here, okay, you don't have a number up above, but you do need to subtract 9. Okay, in order to be able to do this subtraction problem, you have to put a 0 up here. Okay, you do not just pull that 9 down. You must put a 0 up above because you are subtracting. Okay, and it's this, what's up here, minus 9. When there is nothing up here, you need to fill it in with the 0, because then it becomes obvious to you that what you need to do is to trade, and that this 5 would become 4, this 0 would become 10, and now you can subtract 10 minus 9 equals 1. 4 minus 2 equals 2. Decimal point 1, 1, 1. Okay, so in this case, when that missing number, when that missing digit, that 0, is not in the top number of the subtraction problem, you're going to want to fill it in to make sure that you're doing your subtraction correctly, or you will end up with an incorrect answer. And I have seen where some of you are doing that, where you're just simply bringing down that digit, and that's not what you do. You need to actually subtract it from a 10. Okay, so you do need to make sure you fill in a 0 up above. So that's why I said sometimes when you're doing addition, even though you're doing addition, it's a good idea to get into the habit sometimes of filling in that 0 so that you don't forget to do it over here where it's necessary. All right, looking at the other problems, you have addition of fractions with like denominators in number 13. Number 14, subtraction of fraction with like denominators. 15, subtraction of fractions with like denominators. Remember, when you have like denominators, the denominator stays the same. You only do the addition and the subtraction of your numerators. Number 16, you have multiplication, so you set that up vertically so you can work that out. 17, you have a division problem. Set it up using the bracket so you can go through all the steps that's necessary there. Number 18, you have what looks like an improper fraction, but you also know that to be a division problem. But again, set it up with the bracket so you can go through the steps of long division. 19, long division. And then you have 20. Now pay attention where in 20 you have an A, a B, and a C. And basically they're asking you to reduce each fraction. Okay, reduce each. It's not a choice. It's not a multiple choice answer. Number 20 has 3 parts, A, B, and C, and you need to reduce each fraction. Now, how do you reduce the fraction? Remember that whatever you do to the numerator, you must also do to the denominator. So when we are reducing, reduce means to make smaller. So when we are reducing fractions, you're going to be dividing. But whatever you divide the numerator by, you must also divide the denominator by. So you have to first look to see what can you divide each the numerator and the denominator by so that it goes evenly. When you're reducing fractions, you're not working with remainders, okay? It must go evenly. All right, so for today, you need to finish off the review doing numbers 11 to 20 on your own. Okay? And again, with any of this, even any of the problems that we have gone over already together, if you have questions or you're not sure or something's confusing to you, please, you do need to reach out to me so that I can help you. I want to make sure that you understand these skills that we're working on here. Okay? So please make sure you let me know if I can help you. Don't forget to spend some extra time in extra math and or IXL depending on what you're currently working on. Okay? So I'll talk to you later. Bye.